Okay, this is probably going to be quite a short one, mainly because I know which cation I've got here. But we have identified all of these ones so far. We've said we're not going to spend our time on these two because they don't do any chemical reactions that we need to write up. So we're going to look at now, this will either be lead, zinc or magnesium. With all of these, I start by adding 2 to 3 drops of sodium hydroxide and I get a white precipitate. And I'd expect that with all of these 3 salts. Then I add excess and you'll see that that has stayed cloudy. So I'll just add a little bit more to make sure. And yeah, it's still cloudy. So if it stays cloudy, that means the precipitate has remained. There's only 2 things which it could be then, is barium or magnesium. Because I've worked with barium already in a previous video, I know it's not that, but the way that I confirm that it's not barium is I'd take a fresh sample of that same solution, which I'm about to do now, and I would add some sulfuric acid to it. And I'm normally quite liberal with my sulfuric acid to make sure I've got lots of sulfate ions in there. And look, it stayed clear and colourless, so no reaction. So that means it's not barium. So how do I write this up? Okay, well the first thing I did was I added 2 to 3 drops, then excess sodium hydroxide. And what I got there was a white precipitate which remains. Then I took a new sample and I added H2SO4 and there was no change, so no reaction. No reaction means I don't have to write a chemical equation for it, but the one at the top has precipitation, so I do. Now I know that this means it's not barium, so I know that it's magnesium. Now I know this, I can fill in my equation for this one. Mg2 plus 2OH minus, coming from the sodium hydroxide, leave the sodium out, it's a spectator, makes MgOH2, which is our solid, which is the white precipitate we saw.